Hello everyone and Dr. Humawan specifically. For this video recording, I'll be reviewing the code and do demo for the Coursework1B result. So let's begin with the main flowchart. So this is the main flowchart of the conveyor belt design. I'll be referring to this flowchart when explaining for the button state. So let's begin. So basically this is the first part of the code. What I did here is just include the header file for our controller, which is the H63ECH, and then I configure this. And then first step is just to go to the button. So at this button is for the start button and the end button. So what I did here is that I just clear TCP&D and then make the port as output. And then here is I select RB4 and RB5 as the input. So the idea is that if RB4 is pressed, then it start the program, and then if RB5 is pressed, then it terminate the program. So firstly I choose configuration bit here. I set icon to this hex value where it make the RA0, RA1 and RA3 analog and others digital, and then I select display 4 for the state display, and then after select, I set. Is how we can make the RB4 as the start button and then RB5 as the stop button. So firstly I just check B1. I just check if RB4 is push. I put this in this check B1, and then I go to check B2 to check if the RB5 is push, and then check B1 again. So if RB4 is push, it will go to on B1, on button 1. So at on button 1, it will display 1 at port D, which is the display, because previously we already set the display 4 to display our state, and then I go to off B1. So at here I just check if RB4 is released. So once it's released, it will go to the ADC conversion. First we clear port D. So for this one, since we check B2, if B2 is push, then it will go to on button 2 on B2. So at B2 display 3. Actually we don't need, but I will just do it. And then copy it to port D. And then since B2 is for end the program, so I just go to this one, PWM, and LED off, where I set the port C, which is the one that execute the PWM, and then ADB all clear. And then I make a loop here so it doesn't go start again, so it doesn't keep running. So this is the state diagram for the second state, which is the ADC conversion. This is the detailed version of the conversion part. I'll be inserting the code and explain it together with the main with the flowchart. So let's begin. This is the first conversion of the ADC for lower range, which mine is 0.4 volts, using the student ID for the calculation. Okay, so what happened here is that I make firstly I make all port D as an output, and then at icon 1 I just define the result formatting and then the configuration bit, where here I make it left justified. So we need 10 bit, 8 from address H and then 2 from address L, and then at here I just choose the configuration bit where port A0 and A1 is analog, and then I set display 4 as the digital output, and then here is to display the state like 1, 2 or 3, and then for icon 0 is for the control configuration for the A to D conversion, A to D module. So this one is the clock conversion, which mine is here, this one. And then for the channel, I choose the RA0, and then here I just turn on the A2 module. And then at this part is where the conversion happen, and then go to check, and then at this part I just move the address H8 bits to K, and then I subtract it with the W, where mine is 74 in decimal or in this 8-bit binary. And then I set the C status as 0. So here means that if it's equals to 0.4 or above, I will go to display. If it's not, it will go to 1 display. So here is the second conversion of the ADC conversion for the upper range. This one is for the upper range, where mine here is 0.6 volt. Basically it's just the same as the one I did in the first conversion, just that here if it's above 0.6 or equal, you'll go to display. If it's not, then you go to display. So for 3 display, firstly I just set port A display 4, and then display 3 at that one, and then load it into port D. So to define at which state it is, so I just light up LED 1 and LED 3. Here I clear it and turn it off to indicate that it's turned off. And then I go to PWM. This one is to turn on the fan. So if it goes to 2 display, I display 2 at the display 4, and then similarly I just set LED 1 and then LED 2 and then clear LED 3 to indicate that it's in second state right now. So here I just this one is for the PWM to make sure it turn off. For one display, it's just the same. I display 1 to port A and then load it to port D, and then I light LED 1. This one is clear LED 2 and 3 to indicate that we are in the first state, because LED 1 is light up. Okay, and then just go back. Here is to setting the prescaler. This one is for the PWM, and then go back to start. Okay, so for the PWM, this is what it looks like, the flowchart. Okay, so at the code, I'll be referring to this. First thing I do is to disable the CCP1 output driver as an input by setting it to by setting the tris2 bit, and then I set the PWM period, which mine is 35 based on the calculation using the student ID, and then move it into the PR2 register. And then after that is that here I set the CCP1 con into a PWM mode, and then load the value into the CCP1 con, and then I set the duty cycle value, which mine is here is 58 and here is displayed in binary. I moved the binary bit into the CCPR1L and then configure the CCP module by loading it into the CCP1 con. Here is bit 5 and 4. So then I configure and start timer 2 by first clearing the timer 2 interrupt flag and then set the timer 2 prescale value, and then after that just enable the timer 2 at, at this one. At the end I just made a modification where I light LED 3 to indicate that it's in the third state, and then off LED 2 and then go to final. This one to check if RB5 pushed. Yeah, and then go to the button state. Okay, so here I will be simulating the design on the PIC lab, and this is the whole code, the one I have just explained just now. Okay, so I will load this file in, I will build all and then create a hex file for it. So, and then I will load it into the PIC lab to simulate. Okay, so now let's load the file, the coursework file. Okay, so before that, I actually make the, first we need to turn on the port for RAO is for the potentiometer, and then RC2 for the fan, and then the RA5 for the display 4, we need to display the state, and then the port B for LED. Okay, then RB4 and RB5 light up because we set them as an input. Okay, so now I will press RB4 to enter the first state. Here it shows 1, indicating it entered the first state. And now I'm playing with the potentiometer to enter the second state. Okay, so then it reached 0.4 volt. That's why it displays true. So later, if it reach above 0.6 volt, it will go to third state. Yeah, and the fan is on. LED 1 lights up, LED 3 lights up, LED 2 gone, because we already set them off, indicating we are in third state. Okay, so if you didn't press anything, it will still be in the third state. So if we press RB5, it will terminate the whole thing. Yeah, so now it's off. Okay, finally we reached the end of my demo presentation. I hope you understand and like it. So thank you very much and have a good day.